Hi everyone, welcome back. In this video, we are going to cover part 2 of ML fundamentals. In part 1, we covered what ML is, how it differs from classical programming, and the three broad categories: supervised, unsupervised, and reinforcement learning. If you haven't watched part 1 yet, link is in the description, go watch it first. It will make everything in this video click much faster. Now, in part 2, we are going to break down each ML category with detailed banking stories, classification, regression, customer segmentation, fraud detection, and a live trading bot powered by reinforcement learning. By the end of this video, you wouldn't just know what these techniques are, you will understand exactly how they work inside a real bank. So, let's get into it. Alright, so now that you understand the three broad categories of machine learning, that is supervised, unsupervised, and reinforcement learning, let's deep dive into each type. Started with supervised learning and specifically its first type, classification. Now imagine you are a loan officer at a bank. Every single day, hundreds of loan applications land on your desk. Your job is simple: look at the application and give one answer: approve or reject. That's exactly what binary classification does. The model looks at the input features, things like the customer civil score, their monthly income, existing EMIs, employment type, and the loan amount requested, and it outputs one of the two values, either 1, which is approve, or 0, which is reject. So we get only two possibilities. That's it. That's the binary classification. But now, let's say your bank wants to go one step deeper. Not just yes or no, but how risky is this customer is. That's where multi-class classification comes in. Now the model doesn't just say approve or reject, it assigns the customer to a risk category. Low risk, where the customer is a safe borrower, bank can offer them premium products and the best interest rates. Then we have medium risk, where customer can get a standard loan with slightly higher interest rate. High risk, where the customer can get small loan amount only with collateral required. At very high risk, we will reject the application or offer only secured lending. See the difference? In binary, you get a yes or no. In multi-class, you get a different category, and that allows the bank to make smarter, more personalized decisions. On AWS, services like Amazon SageMaker and Amazon Fraud Detector are used to build and deploy these classification models at scale. So the next time you apply for a loan and get an instant decision, that's not a human making that call. That's a classification model trained on millions of past applications doing the work in milliseconds. Okay, great. So we have covered classification. Now let's talk about the second type of supervised learning. And this one is a bit different. It's called regression. Here's the key question to ask yourself: what is the model trying to output? In classification, the output is a category: approve or reject, low risk or high risk. In regression, the output is an exact number. Let me bring this to life with a banking story. Let's say we have a customer Jack. He's a 35 years old, earns 80,000 per month and has a 8 years of work experience, a CIBIL score of 780 and currently pays 12,000 in existing EMIs. Jack walks into his bank and asks, "How much home loan can I get?" Now, a traditional banker might sit down, open a spreadsheet, apply some thumb rules, and come back after 30 minutes. But with a regression model, this happens instantly. The model takes all of Jack's features as inputs, for example, salary, experience, civil score, EMI, age, and many more, and runs them through a mathematical function it has learned from thousands of past loan cases, and outputs a single number. Let's say 18 lakh 15,000 is a recommended loan amount. But it doesn't stop there. The model also recommends EMI of 24,500 per month, which is 30.6% of his income, that is within the safe threshold, with a tenure of 10 years and an interest rate of 8.75%, because Jack falls in the low risk tier. That's the power of regression. It doesn't just classify, it quantifies. On AWS, the Amazon SageMaker linear learner algorithm is the go-to tool for this. It's used for anywhere you need to predict a precise numerical outcome. Now let's move into the unsupervised learning. We have been talking about supervised learning, where the model learns from labeled data. Someone has already told it the right answers. But what happens when you have no labels? No one has told you what's fraud and what's not. No one has categorized your customer, you just have raw data, millions of transactions, millions of profiles, and you need to find patterns on your own. That's unsupervised learning. And in banking, it's absolutely everywhere. Let me walk you through four powerful techniques. Number one, customer analysis or customer segmentation. Imagine a bank with 10 million customers, completely different people, different ages, incomes, transaction, habits, and investment preferences. How do you serve them all differently without manually grouping them? You let the model do it. Unsupervised clustering algorithms automatically group these 10 million customers into meaningful segments. Let's say HNI investors, young professionals, retirees, SME business owners, without anyone telling it those categories upfront. Now the bank can send targeted product offers to each group, no more one size fits all marketing. Number two, we have anomaly detection for fraud. Remember our fraud example from previous part 1? Let's revisit through the lens of unsupervised learning. A customer based in New York makes transaction every day at a coffee shop, grocery stores, UPI payments. The model learns this customer's normal pattern. Then one night at 2 a.m., a 2 lakh transaction fires from Dubai. The model doesn't need a label that says this is fraud. It just knows this deviates massively from the established pattern. Fraud alert raised instantly. That's anomaly detection. The model learns what normal looks like and flags everything that isn't. Number three, we have dimension reduction. Here is a real challenge in banking. A loan application might have 200 different features: credit scores, salary, rent, utility, shopping habits, device data, and etc. The list goes on. Training a model on 200 features is slow and expensive, and many of those features carry overlapping information. So, what is the solution for this? PCA. PCA is the principal component analysis. It is one of the techniques that compresses those 200 features into just 15 principal components, preserving the most important information and discarding the noise. That result into faster model training, lower compute cost, same or even better accuracy. Number 4, we have density estimation for market risk. This one's more advanced but incredibly important. Bank needs to prepare for rare extreme events, market crashes, currency collapses, liquidity crisis, and many more. These are called tail risk scenarios. Density estimation models analyze historical data distributions to understand how likely extreme events are. It helps risk management teams build portfolios that can survive extreme events. So, in summary, unsupervised learning is the bank's detective. It finds structure, patterns, and anomalies in data that no one has labeled for it. It's working silently in the background every single day. And now we arrive at the most exciting category of all: reinforcement learning. Let me ask you a question. How does a child learn to walk? Nobody gives them labeled dataset. Nobody tells them move left foot first, then right. They just try. They fall, they get up, they try again. Slightly different approach. And over thousands of iterations, they figure it out. That's a reinforcement learning. Learning by trial and error, guided by reward signals. Let's bring this into banking with one of the most dramatic use case, the algorithm trading bot. Let's say the environment is the stock market that is alive, real time, and unpredictable. The agent is a trading bot, and its only goal is to maximize profit. At any given moment, the bot observes the state. Maybe Nifty is down 10%, FFI are selling, the rupee is weak. Based on this state, the bot takes an action. It decides to buy 500 shares of a stock at rupees 1840. The market responds, the stock moves up, the bot made a 24,000 profit. That profit is in the reward signal. The bot notes this: in this type of market state, this action worked well. It updates its policy, its internal strategy accordingly. Next time it sees similar condition, it will be more likely to make that same move. And when it loses money, it updates its policy in the other direction. Over millions of simulated trades, the bot becomes extraordinarily good at reading markets and making decisions without a single human writing a trading rule. This same RL framework powers other critical banking use case, for example, dynamic interest rate, where the model auto adjusts rates in real time based on market conditions and competitor behavior. ATM cache optimization, it predicts how much cash each ATM needs on a given day, preventing both shortages and excess idle cash. Portfolio rebalancing, as market shifts, the model automatically rebalances investments to maintain the desired risk return profile. On AWS Deep Racer is a fun way to get started with the RL, and Amazon SageMaker RL is the production grade tool used for real banking applications. The key thing to remember, RL doesn't need label data. It learns purely from interacting with its environment and receiving feedback. That's what makes it so powerful and so different from everything else we have discussed. Alright everyone, we have covered a lot of ground today. Let's bring it all together with a quick summary before we close. We learned about supervised learning and its type, classification and regression. We talked about unsupervised learning where we have discussed clustering, anomaly detection, dimensity reduction and density estimation. And in last, we discussed reinforcement learning, where we talked about algorithm trading bots, dynamic interest rate, ATM cache optimization, and portfolio rebalancing. And that's a wrap on machine learning fundamentals in the banking domain. If you found this valuable, please hit like, subscribe, and drop a comment below. I would love to know which banking ML use case surprised you the most. In our next video, we go deeper into AWS SageMaker, model training and deployment, and ML ops on AWS. That's where things are really get interesting. See you in the next one. Take care.